Okay, so we continue our discussions. Okay. Okay. So from the problem, okay. So from the first problem we have discussed, this formula, okay, of shear stress is a general formula in which you can compute the shear at any point of your uh, beam, okay, at any point of the cross-sectional area of the beam, whether it is located here, located at the middle, okay, at any point, okay, as long as you know its location relative from the top or from the bottom um, of your of the cross-sectional area of your beam. Okay, so maybe I will erase, okay, maybe I will erase our solution from the previous video. So here, okay, let us revisit our the different cross-sectional areas, possible cross-sectional areas of your beam. Okay, let's start with um, a rectangle, okay, circular, let us say an I-beam, or an I-section, a triangle, and a trapezoid. Okay. Okay, so since we all know, okay, so the neutral axis, or the point in which the neutral axis is located in your in a rectangle. Okay, so more likely your shear, your maximum shear is located also at the middle. Okay, so remember, as I remember, this is a parabolic curve. And also at the top and at the bottom, it will experience a zero. Okay, the shear here is equivalent to zero. Okay, so this equation, okay, so from is applicable as long as we all know what is, okay, what is the location of that point. Okay, let us say a point A, okay, let us say y sub 1 from the neutral axis. And more likely, okay, its centroid is located at the mid height. No, let H, this is H. Okay, so also for circular, okay, for circle, for a circular cross section, its centroid, or the location of its neutral axis, is at the mid height also. So if your I-beam, okay, for I sections in which has a uniform thickness of its webs, okay, so these are the webs and the flange. So if it has a height of h, the location of its neutral axis is also h over 2. But somehow, for the case of a triangular cross-section, the location of its neutral axis is more like is located, okay, 2h/3 from the top and h/3 at the bottom. Okay. So, but it is different if it is turned, this triangle is turned upside down. And then, most probably, your trapezoid, you need to compute. Okay? You need to compute first. Okay? You need to divide first your cross-section into triangle and a rectangle, into two triangles and rectangle in order to compute the location of your neutral axis or the location of your centroid. Okay? So when we say neutral axis, I want to clarify this neutral axis is a horizontal line crossing at your centroid, the location of your centroid. So this we do not know. Okay? So here, most likely it's a shear stress diagram. Okay, we talk about shear stress diagram. So it's a shear stress diagram will be also like this, in which that your tau max or your maximum shear is located also at the middle, since its neutral axis is located at the middle. Also for DI section. For triangle, more likely it's quite skewed. Okay, it's skewed at the bottom. So more likely it will be like this. Okay, so it's quite unsymmetrical. Its distribution of shear is quite unsymmetrical. So this will be location of your maximum shear. Also, its shear at the sides will be equal to 0. Also, in this one, okay? So, it could be slightly skewed downward or upward depending on the shape of your cross-section. Okay? So, not all the time that that your shear stress diagram is a symmetrical parabola in form. It could be also skewed. Okay? So that is it. Okay? Okay. So speaking of Q, I have one more. Okay? We will have, I want to explain, okay, what Q will you use. Okay, so there will be two Q. Okay, there will be a Q top and Q bottom respectively. For example, let us have the simplest cross-section area, the rectangle. Okay, so when you are okay, so we have its neutral axis located at h/2. Okay, so since our total depth is h and base b, okay? Okay. And this will be your stress diagram, okay? So what if, okay? So when computing, okay, so let us say we need to find the value of this shear stress here, okay? So we want to know the value of your shear stress at this location. So what will you use? You use logically your Q top. Okay? So if it is, okay, so since let us base from the neutral axis. So from the neutral axis you will measure your y bar, okay, from the neutral axis to the centroid of this area. Okay, centroid of this area. The area above the point in which you want to know the shear stress. But there is, okay, so what will you use is the Q at the top, okay? So for top, okay, if you want, okay, so if it is above neutral axis, okay, you measure, okay, measure your Y bar from the top, okay? And then also Q and A from the top also. And if it is below the neutral axis, okay, measure Y bar from the bottom. And also your Q and A, you measure, okay, you compute from the bottom also, okay? So let us say um, the location of your point is, you want to know the shear stress of this point, okay? So you draw a line from that point, and then from this point downward, okay, so if it is located below the neutral axis, you form an area. Okay, so you compute now here, okay, so let us say from the bottom, you compute now your Q as A multiplied by Y bar. And then your Y bar is measured from the centroid of that area to the neutral axis. So your Y bar, you will measure now from the bottom, okay? So that is if the point you are referring to is located at the bottom, okay? So that is how you compute your shear stress, okay? Your shear stress at any point on your beam. So that is it, okay? So that is how you compute your first moment of area. So if it is located at the top, above the neutral axis, measure your Y bar from the top. And then your Q and A should be located also at the top, from the top. And then if the location of the point you want to compute the shear stress is located from the bottom, then measure your Y bar from the bottom. And also your area, or your Q and your area should be located also at the bottom. Okay? So that is how you compute your first moment of area, or your Q. And another one is the base. Okay. So what if, okay, for the base, okay, your base, it depends upon the location, okay? So if you want to, let us say the location, your shear stress is located here. So we have no problem with a rectangular beam since its B is uniform throughout. But somehow for a circle, let us say that we need to find your shear stress here. So what you are going to do is to compute this AQ here, okay? So therefore, your B here, your instantaneous B here will be this. Okay? So this will be your B. This will be your B. Okay? So here, at okay, for I section, you have two different B. So if you want to know the shear stress somewhere at the top or at the web portion, let us say here. So your B here will be this. And if you want to compute the shear stress, if it is located at the flange, so your B here is this one, much smaller. Is the width of your flange. Here, it is the width of your web. So there will be two different B. So also for your triangle, your B will vary. Okay, so if you want to know the shear stress at this point, that your B here will, the measurement of your B is this. This will be your B. Of course, and also for your trapezoid. Okay, so if we say that you want to know the shear stress at this point, your Q will be here. Q is equal to AY bar. And then your B is here. B. Okay? The width at the bottom. Okay? So please take note of that. Okay?